Happy morning to all. Happy morning. Okay. Anyhow, today our learning objectives to learn about potassium permanganate. To learn about potassium permanganate. Here, all of you know about the potassium permanganate. The formula for potassium permanganate is KMnO4. That's the potassium, Mn and oxygen. Potassium permanganate. There. And about it is prepared from pyrolysis. There is MnO2. This preparation involves two steps. One is the conversion of the MnO2 to potassium manganate. First step is the O, pyrolysis, there is MnO2. It is converted into potassium manganate. The formula is K2MnO4. Okay? The first step, conversion of the powdered pyrolysis O, that is MnO2 is converted into potassium manganate, that is K2MnO4. The second step is potassium oxidation of potassium manganate to potassium permanganate. The oxidation, okay, second step is the oxidation of potassium manganate to potassium permanganate. Here, the oxidation has two steps. One is by chemical oxidation, another one is on electrolytic oxidation. First one is chemical oxidation, another one is on electrolytic oxidation. Okay, these are the two steps having the preparation of potassium permanganate. Here, the first one is the O is finely powdered. The O is finely powdered and fused with potassium hydroxide in the presence of air. Okay. First one is the powdered MnO2 is fused with KOH in the presence of air. Otherwise, it can be used as an oxidizing agent, that is potassium nitrate or potassium chloride. It can be used as potassium nitrate or potassium chloride. We get a green colored one of a compound. Green colored compound that is called potassium manganate. Potassium manganate formula K2MnO4. The second step is the oxidation of potassium manganate to potassium permanganate. For that we are taking manganate ion, that is MnO4 2- plus with ozone and water. These are the three items we are taking. One is manganate ion, that is MnO4 2- ion plus ozone plus water. We get what? MnO4 minus ion, that is permanganate ion. Otherwise, manganate ion with chlorine, we get permanganate ion. These are the steps for this reaction. So let us, we can write the equation and also we can balance the equation. Okay, this is very important. So let us please all of you take your note and we can write the equation and how can we balance the equation. Okay. Potassium permanganate. Formula for potassium permanganate is KMnO4. Okay. The formula for potassium permanganate is KMnO4. Potassium permanganate. It is prepared from pyrolysis, that is MnO2. Okay. MnO2. This preparation involves two steps. One is the conversion of MnO2 to potassium potassium manganate. Next one is oxidation of potassium manganate to potassium permanganate. Like that, two steps. Okay? It following two steps. What is the first one? That is the conversion of MnO2 to potassium manganate. Second one is oxidation of potassium manganate to potassium permanganate. So two steps are involved. Okay. The first one is the powdered ore is fused with potassium hydroxide with the presence of air. Here, the powdered ore is fused with KOH. Which ore is powdered? Pyrolysis. That is MnO2 ore is powdered. Clear? The first one is the powdered ore is fused with KOH. That is MnO2 is fused with KOH in the presence of air. Okay. In the presence of air. Otherwise, we can be used as an oxidizing agent like KMnO3. KMnO3. Clear? Otherwise, we can be used the oxidizing agent like K. What is KMnO3? Potassium nitrate. Otherwise, another one we can be used as potassium chlorate. These are the reagents which can be used. Okay. Here, what is absorbed means we get a green colored potassium manganese is formed. Okay. What is the first one? Conversion of MnO2 to potassium manganate, K2MnO4. This is potassium manganate. Okay. Here the first step, that is MnO2. This is a powdered ore is fused with KOH. KOH with the presence of air. Otherwise, an oxidizing agent such as potassium nitrate or potassium chlorate. What is the formula for potassium nitrate? KMnO3. What is the formula for potassium chlorate? KClO3. KClO3. What is obtained here? A green colored potassium manganate. What's the product? A green colored potassium manganate, that is K2MnO4. Okay? K2MnO4 with the evolution of water. Okay? This is the equation. So one of the important questions, how can we balance the equation? Here having one hydrogen, here having two hydrogen. So it is not possible to balance two. Yes, we can make it here two. Make it here 2. 2H2O. Clear? 2H2O. We are adding how much hydrogen? 4 hydrogen. So make it 4 here. Clear? Now how much potassium is there? 4 potassium. Here only 2 potassium. So make it 2 here. Okay. How much Mn here? 2. So also make it 2. I think that the equation is balanced. Am I right? We balance how much Mn? 2 Mn and 2 Mn. And about how much potassium? 4 potassium. 4 potassium. And about the oxygen? 2 plus 4, 6. 6 plus 2, 8. Here, 4 into 2, 8. 8 plus 2, 10. Here, 2 into 2, 4. 4 plus 4, 4 plus 8 plus 2, 10. Here, 2, 4, 8, and 10. Okay. Now everything balanced. What about the hydrogen? 4 hydrogen, 4 hydrogen. Everything is balanced. Next, this is the formula for potassium manganate. What is the color of potassium manganate? Green color. Which color? Green. Potassium manganate. Okay? Okay. And second step, this is the first step is over, that the first conversion is over. After finishing the conversion, next is one is called oxidation. Okay? Second step is an oxidation. Oxidation of potassium manganate to potassium permanganate. Oxidation of potassium manganate formula K2MnO4 to potassium permanganate KMnO4. Okay, here the potassium permanganate is obtained by oxidation two ways. This is also having oxidation two ways. The one is either by chemical oxidation, other by electrolytic oxidation. First one is chemical oxidation. Another one is the electrolytic. Okay, here the oxidation of potassium manganate to potassium permanganate involves two ways. One is either by chemical oxidation or electrolytic oxidation. Okay, here. Next about the chemical oxidation. What is about the chemical oxidation? Potassium manganate is treated with ozone or chlorine. Here, what is the formula for potassium manganate? KMnO4. Potassium manganate. Here. This potassium manganate, we are taking as per our textbook, we are taking only the manganate ion. Here, the manganate ion, that is 2 minus, which on reacts with ozone. What is the formula for ozone? O3. Otherwise, we can be taken as chlorine. Okay, O3 or chlorine. Here, O3 we are taking means you should be add water. Okay, suppose we are taking O3, that is the reaction between manganate ion with O3. What we get? Here we get MnO4 minus ion. What is MnO4 minus ion? That is a permanganate, okay. Permanganate ion, including which we get the water is converted to OH minus ion, hydroxyl group ion. Okay, and also the evolution of oxygen. Here, this is a manganate ion is converted into permanganate ion. Here, the manganate ion, for example, if we are adding potassium, we get K2 MnO4. Potassium manganate is converted into KMnO4. What is KMnO4? Potassium permanganate. As our textbook, we are taking the potassium. Okay, so we get manganate is converted into permanganate. Here, am I right? Then how can you balance the equation? First of all, you should make it 2 here. Make it 2 because the reason the oxygen is not balanced. So first of all, you are making 2 here. Then you can also make it 2. Clear? And about the hydrogen here having 2, okay, hydrogen having 2, so also make it 2 here. Now we can balance everything. 2 manganese, here also 2 manganese, okay. And about the oxygen, 2 4s are 8 plus 3, that is 11 plus 1, 12, clear? What about here? 2 4s are 8 plus 2, 10 plus 2, 12, clear? And about the hydrogen, 2 H2, okay? Everything is balanced. The second step, here the manganate ion, MnO4, 2 minus ion, that is a manganate ion, on reacts with the chlorine. Okay, on reacts with the chlorine, we get MnO4. MnO4 minus ion, and also we get 2Cl minus ion. The chloride, okay, chlorine is converted to chlorine ion. Okay, then how can you balance the equation? Maybe 2 here, 2 here. Now the equation is balanced. Can you write the 2 equation? Have it out? The 2 equation. Next one is electrolytic oxidation. I told you that the chemical oxidation, the chemical The oxidation of potassium manganate to potassium permanganate having two ways. One is either by chemical oxidation or by electrolytic oxidation. This is the equation for chemical oxidation. The both two equation is a chemical oxidation. Suppose we are taking ozone, that is O3 with potassium manganate, means we are adding water. Otherwise, manganate ion with the chlorine we are taking, means no need to add water. We get that product. Okay, anyhow, at least this have two equations. At least you should be learn one equation is enough. Okay, as per your wish, you can be select any one equation is enough as per your choice. Okay, next about the electrolytic oxidation. Electrolytic oxidation. The electrolytic oxidation means when aqueous solution of potassium manganate, is electrolyzed in the presence of little alkali. Here undergoes electrolysis. Electrolysis means by dividing into two ions. One is cation and another one is anion. One becomes a positive charge, another becomes a negative charge. That is called what? That is about the electrolysis. Okay. We are taking manganese ion, potassium manganate, that is KMnO4, K2MnO4. Okay, here K2MnO4 is undergoes electrolysis in the presence of a trace of a little of alkali, a small amount of alkali. What happened? The potassium is leaving out, potassium K plus MnO4 minus, MnO4 minus. This is divided into, it is split up into two ions, MnO4, 2 minus. That means potassium manganate is split up into potassium plus manganate ion. Okay, potassium plus and manganate ion. Can you write? And about how can you balance the equation? Here I have 2 potassium, take it 2 here. Manganate, everything is balanced. Next about water. Water undergoes dissociation. Can you see what's the product? H plus OH minus. Divided like that, H and OH. Here, these are the two equations. Have it out. One is the electrolytic oxidation. Then the electrolytic oxidation, in this method, the aqueous solution of potassium manganate is electrolyzed in the presence of little alkali. Okay, in this method, the aqueous solution of potassium manganate undergoes dissociation, electrolyzed. Okay, in the presence of K plus manganate ion. And also we are taking water, aqueous solution of water is divided into two ions. One is H plus and one is OH minus ion. Next one, manganate ions are converted into permanganate. Can you say what is the color of manganate ion? Previously I told you. What is the color of manganate ions? That is green color. Potassium manganate is a green color. And permanganate, purple color. Okay. And about manganate ion, that is MnO4 2 minus. This is what? Manganate ion. What's the color? Green color. It is converted into purple color. That is MnO4 minus ion. MnO4 minus, okay? Plus, including we should add the electron. 2 electrons. Okay. 2 electrons. Then manganate ion is converted into permanganate ion. Manganate ion is converted into permanganate ion. Here potassium manganate undergoes dissociation, otherwise split into potassium plus manganate ion. Water also divided into H plus and OH minus ion. Here this is about the manganate ion. This manganate ion is converted into here permanganate ion, here permanganate ion, okay. And above, where it occurs in the anode. This reaction is occur where? In the anode reaction. Did you heard the name anode? Anode, cathode. Anode means positive charge. Cathode means negative charge. Here, anode. This is a positive reaction. Positive. Okay. Anode in the positive side is a positive reaction. Next about the cathode. Cathode we are taking H plus ions. Clear? The cathode we are taking hydrogen. Hydrogen is liberated. Hydrogen is liberated at the cathode. Hydrogen is liberated at cathode. Hydrogen is liberated at cathode. That is 2H plus ion plus 2 electrons. Here adding 2 electrons. 2H plus ion plus 2 electron. 2H plus ion, 2 electron. We get H2. This reaction is occur where? At the cathode. Here, the purple color of solution is concentrated by evaporation and forms a crystals of potassium permanganate on cooling. Here, this is the final. The purple color solution is concentrated by evaporation and forms a crystals of potassium permanganate on cooling. This is about the potassium permanganate reactions. Okay. Next about what are the physical properties of potassium permanganate. This is a important question for the 2-mark question. At least you should be learn 3 points. Okay. What are the physical properties? What are the physical properties of potassium permanganate? Okay, it is a purple crystal. It's a dark. Okay, then like that you can be saying dark purple crystal. And about this melts 530 Kelvin melts. Okay, and it is sparingly soluble in cold water. And sparingly soluble in hot water. These are the 4 points. At least you should learn. Here 3 points is enough. Okay. What is about the physical properties of potassium permanganate? Okay. Potassium permanganate exists in the form of dark purple crystal. Dark purple crystal. Can you learn? Dark purple crystal, which melts at 513 Kelvin. Which melts at 513 Kelvin. It is sparingly soluble in cold water, but fairly soluble in hot water. These are the physical properties of potassium permanganate. Okay, select any 3 points. This is the physical properties of potassium permanganate. Next about structure of permanganate ion. This is also an important question, 2-mark question. Structure. If you know the formula for permanganate, you can draw the structure of permanganate ions. Okay. Permanganate ions. Okay. Permanganate ions has tetrahedral geometry. Tetra. So what's the reason? The central space, the central is Mn. Mn is occupying, Mn2 plus is occupying, Mn7 plus is occupying, and the four oxygen atom are surrounding occupying. Okay. And about the hybridization is sp3 hybridized. What is the hybridization? sp3. Okay, don't forget sp3, and the oxidation state is +7. Here the oxidation state is +7. The previous video I told you about that. How to calculate the oxidation number. And also if you have any doubt, please call me. I help you. Okay, and about that, the previous video also I told you that the hybridization. Okay, everything is I told you. If you have a doubt, we can be solving this one. And about the structure, Mn is occupying at the center. And about the oxygen, how much oxygen is there? Only one Mn. How much oxygen is there? 4 oxygen. 1, 2, 3, 4 oxygen. Okay, as per the 3D view, you can draw one more line. Okay. Okay, structure of permanganate ion. Structure of permanganate here. And one more also structure having one more structure. It's manganese at the center. So oxygen. Oxygens are surrounded by 4 different sides. This is our structure, and clear. And don't forget that about the 2 points you should write. One is it has the tetrahedral geometry. What's the geometry? Tetrahedral geometry, and the oxidation state is a +7. Next one is sp3 hybridized. The 3 points. Okay, don't forget the 3 points. What is the geometry? The permanganate ions, tetrahedral geometry. Tetrahedral geometry, and which is the central metal is Mn2 plus Mn3, Mn7 plus ion, and about the hybridization is sp3. Don't forget that the hybridization is sp3. Here, next about what are the chemical properties of potassium permanganate. What are the chemical properties about the potassium permanganate? One is about the decomposition reaction. Potassium permanganate undergoes heating, we get potassium manganate, and next one is potassium permanganate react with sulfuric acid, we get manganese heptoxide. The next one is potassium permanganate react with sulfuric acid, we get that's a concentrated sulfuric acid, we get manganese sulfate, potassium sulfate, water and oxygen. These are the three reactions. Okay, three reactions. The first one is action of heat is very important. Action of heat about the potassium permanganate. Okay, it's a KMnO4. Potassium permanganate action of heat undergoes decomposition on heating. Decomposition. To decompose potassium manganate is K2 MnO4. K2 MnO4 plus MnO2 plus O2. Okay, potassium permanganate on heating, on decomposition, when heated, potassium permanganate decomposes to form potassium manganate, manganese dioxide and water and oxygen, and oxygen. Potassium permanganate on heating we get potassium manganate, manganese dioxide and oxygen. How can you balance the equation? The balance the equation is very important. How can you balance the equation? Here having 2 potassium, make it 2 here. So how much manganese here? 2. Now the equation is, I think the equation is balanced. Here 2 potassium, 2 manganese, oxygen 8, 4 plus 2, 6 plus 1. Okay. Next about action of concentrated sulfuric acid. Action of concentrated sulfuric acid. Here, on treating with the cold concentrated sulfuric acid, it decomposes to form manganese heptoxide. Here, that is KMnO4. Potassium permanganate on reacts with sulfuric acid. On react sulfuric acid, we get manganese heptoxide, that is Mn2O7 plus potassium bisulfate KHSO4 and also having hydrogen, so water is formed. Here, potassium permanganate, this is a cold condition. Potassium permanganate reacts with the cold condition of concentrated sulfuric acid. It decomposes to form manganese heptoxide. The formula is Mn2O7 with potassium bisulfate and water. How can you balance the equation? Here I have Mn2 here, so make it 2 here. So how much potassium? 2 potassium there, 2 potassium, so make it 2 potassium. Next about hydrogen. Hydrogen here having 2, they are having 4. What about the sulfate? Sulfate also having here 2 sulfate, so make it 2 here. Now the equation is balanced, am I right? 2 potassium, 2 manganese, sulfate also 2, hydrogen 2 2s are 4, 2 plus 2. Okay, everything is balanced. Clear? Next about manganese heptoxide, that is Mn2O7. Mn2O7 on heating, what's the product? Which on decomposition on heating we get MnO2 plus oxygen. MnO2 plus oxygen. So how can you balance the equation? Here I have 7 oxygen. Here I have 2 plus 2, 4. So make it 2 here. So how much manganese is there? How much manganese? 4. 2 2s are 4. So make it 2, 4 here. Next about oxygen. 7 and 2 is equal to 40. 4 2s are 8. So make it 3 here. Now the equation is balanced. Here. Here. Next about potassium permanganate reacts with hot concentrated sulfuric acid. Potassium permanganate reacts with hot concentrated sulfuric acid. KMnO4. Potassium permanganate or react with hot concentrated sulfuric acid, that is Mn combines with the sulfate to form Mn combines with the sulfate to form MnSO4. Okay, MnSO4. Potassium combines with the sulfate to form K2SO4, and also hydrogen combines oxygen to form water, and also the evolution of oxygen. Then how can we balance the equation? First of all, we make it 2 here. For easiest, we make it 2 here. So how much potassium is there? 4 potassium, am I right? 4 potassium, so make it 4 here. 4 potassium. What about manganese? Now also 4. Okay? So make it 4 here. Now how much sulfate is there? 4 plus 2. 6 sulfate is there. 4 plus 2, 6 sulfate. So make it 6 sulfate is there. What about the water? 6 H2O. So also you make it 6 H2. And oxygen is also balanced. Clear? Come down. Can you balance the equation? Once again, I am explaining once again how to balance the equation. First of all, hot concentrated sulfuric acid, potassium permanganate, on react with concentrated sulfuric acid, hot. First of all, potassium combines with the sulfate. What's the product? K2SO4 plus Mn combines with the sulfate, MnSO4 plus hydrogen combines oxygen to form water plus O2. So, how can you balance? Here I have 2 potassium, here I have only 1 potassium. Here, 1 potassium, so make it what? Make it 2 here. So, how much potassium is there? 4. So, we have to make it 4. How much manganese is there? 4. Now, how much sulfate is there? Here I have 4, here I have 2. 4 plus 2, 6. 6. So 6 water molecules. Now the equation is balanced. Okay? Have it out. Next also we have the important question is oxidation property. The oxidation property we have different reaction, that is different reaction medium. One is a neutral medium, second one is an alkyl medium, next one is an acid medium. Again lot of equation is there. Let us we can discuss the tomorrow class. We have today assignment. The preparation of KMnO4. Preparation of KMnO4. Potassium permanganate. Preparation. Okay. I think that the page number is 115. Page number is 115. 115. Page number. Okay. Anyhow, that is the preparation. First one is the conversion of MnO2 to potassium manganate. Next about the oxidation of potassium manganate to potassium permanganate. Okay. First one is a chemical oxidation. Second one is an electrolytic oxidation. This much is enough. Okay. Today assignment. All of you should write the assignment. Okay. This is a precious time to learn this area. Thank you all. Thank you. Have a nice day.